Okay, section 2.4 is called More with Functions. Basically, we're going to look at two kinds of functions in this section. The first one is called a piecewise function. The second one is called a greatest integer function. When it comes to piecewise functions, you have a function, f of x or g of x, whatever, and you have some different conditions on x. Okay, so like here, f of x is equal to negative 1/2 x plus 2 if x is less than or equal to 0, and f is equal to x minus 1 if x is greater than 0. So the way that I showed how to graph a piecewise function is to first begin by graphing the line, just flat out ignoring the if condition. Okay, so so I've got two lines here. Okay, the first line is y equals negative 1/2 x plus 2. The second line is y equals x minus 1. The first line, y equals negative 1/2 x plus 2, has a y-intercept at 2 and a slope of negative 1/2. Okay, so I'm going up 1 and to the left 2. Up 1 and to the left 2. Down 1 to the right 2. Down 1 to the right 2. Okay, so I would draw in this line. And now I only want to keep the part of the line if x is less than or equal to 0. So here I'm at 0. When I come up to that line that I drew, anything that is 0 or less be kept. Anything that is bigger than 0 would be erased. Okay, and piece 1 is now done. The second piece, y equals x minus 1 if x is greater than 0. Okay, well, I begin by graphing y equals x plus x minus 1, and that's right here. The y-intercept is at 0, negative 1, and I'm going to go up 1 into the right 1. Okay, because I've got a slope of 1. Or I can go down 1 to the left 1. Okay, and so I've got this line here. Now I only want to keep the part of the line where x is greater than 0. So anything less than or equal to 0, I don't want to include. Okay, x is strictly greater than 0, so at 0, negative 1, which is the point where the y-intercept is going to occur, we don't want that to be on the graph. Okay, and so at this point, I would now be done. I have a function, and it's intact for everything in the domain, even at 0. And of course, when it comes to a function, I don't want I don't want it to fail the vertical line test. Suppose I wanted to know the domain of f and the range of f. Well, the domain is all the x values. So if I am at any value here on the x-axis and I look above or below the value, I need to be on the graph. Okay, so well, that's going to happen anywhere. All real numbers. Now the range of f is where I'm scanning the y-axis and I look to the right or to the left, and I need to be on the graph. Okay, well, anywhere that is greater than y equals negative 1 is going to put me on the graph. Okay, negative 1 to infinity. The intercepts are the 2 points where the graph crosses or touches the coordinate axes. And that's going to happen twice, right here at 1, 0 and 0, 2. Okay, suppose I want to know f of 2. Well, 2 is bigger than 0, so I need to plug that into piece 2. 2 minus 1 is 1, so 2, 1 is on the graph. Here's 2, 1. Yeah, that looks good. That's on piece 2. F of negative 2. Okay, negative 2 is less than or equal to 0. So I need to plug negative 2 in for x, in for piece 1. Negative 1/2 times negative 2 is 1, plus 2 is 3. So at negative 2, negative 3, this point here, I need to be on the graph. And yeah, I've got that on the graph already. Okay. Another example, suppose that f of x is equal to x plus 3 if x is between negative 2 and 1, including negative 2. 3 if x is equal to 1, and negative x plus 2 if x is bigger than 1. Okay, a couple things. I want to graph the function, and then I want to state the domain, the range, the intercepts, things like that. So just like before, I'm going to begin by graphing these 3 lines. We got y equal x plus 3, y equal 3, and y equal negative x plus 2. Y equal x plus 3 means that I've got a line with a slope of 1 and a y-intercept at 3. Okay, so here's 0, 3 on the graph. And I've got a y-intercept at 1. So I'm going to, or a slope of 1. So I'm going to go up 1 into the right 1. Okay, or go down 1 to the left 1. And now at negative 2, I want to begin this line. So when y is negative 2, y equals x plus 3. Negative 2 plus 3 is 1. So y is 1. When x is negative 2, y is 1. Yeah, so that's what I've got. Anywhere that's less than 1 needs to be erased. Anywhere that is bigger than 1, okay, if I let y be, or if I let x be 1, 1 plus 3 is 4. And so now that point is not on the graph. So at 1, 4, I want that not to be on the graph. And anywhere between these two values then is going to be represented. Okay, y equal 3 if x equal 1. Well, that's just going to be a point on the graph. 1, 3. So I'd have a horizontal line at y equal 3. I'm only on one value though. Y is at x equal 1. Okay. And negative x plus 2 if x is greater than 1. Okay, well, here I am at 1. Y equal negative x plus 2 means I've got a y-intercept at 2 and a slope of negative 1. Okay, so I go up 1 into the left 1, up 1 to the left 1, or down 1 to the right 1. Okay, and I want that part of the line, y equals negative x plus 2, to be represented for when x is greater than 1. So here's 1. Anything that's bigger than 1 needs to be on this line. Anything that is 1 or less, I would have to erase if I drew that. Okay, the domain of f is all real numbers such that x is greater than or equal to 2. So here I am at negative 2. Here I am at negative 2. And I guess I can see that from how this function is defined. I'm defined for when x is between negative 2 and 1, including negative 2. I'm including 1 in piece 2, and anything bigger than 1 in piece 3. So really that's anything bigger than or equal, or greater than or equal to negative 2. Okay, you can use set notation or interval notation. I don't care which one. Use or for the range of f. We got the set of all y such that y is less than 4. Okay, and I scan the y-axis, look to the left or the right, and if I'm on the graph, I'm in the range. If I'm not on the graph, I'm not in the range. So here's anywhere bigger than 4. I don't have any graph up here. Okay, anywhere that's less than 4 and less than, not less than or equal to, since 4 has an open circle on it. The intercepts, there's 2 of them. They're at 2, 0, and 0, 3. How about 1, 3? No, that's not an intercept because that's not on the x or y axes. F of 4, okay, well here's negative 4 plus 2 is negative 2. Let me check that. 4, negative 2, that's right there. That's on piece 3 that I drew. F of negative 1, negative 1 is between negative 2 and 1. Negative 1 plus 3 is 2. And negative 1, 2, yeah, that's that point right there. Okay? Suppose we had f of x equals the absolute value of x. Well, the absolute value of x is x if x is greater than or equal to 0, and negative x if x is less than 0. You see, anything coming out of the absolute value bars is never going to be a negative. So this is one way to explain that anything coming out of the absolute value bars is never going to be a negative. Suppose x is negative 6. Then if x is negative 6, then we got the absolute value of negative 6. Now, negative 6 is less than 0. Okay, and so I'm supposed to take the opposite of negative 6, which is positive 6. Okay, well, the opposite of negative 6 is positive 6, so I'm up here. Okay. Otherwise, if x is greater than or equal to 0, you're just going to keep that same number coming out of that function, whatever it is. Okay, so I ended up getting 2 lines. The first line is anything that is greater than or equal to 0. So here I am. Now anything greater than or equal to 0 means that I would disregard anything that is less than 0. Y equals negative x is a line slanted the other way. And x is less than 0. Okay, well I would get rid of anywhere that's in quadrant 4 here. And 0, 0 would end up being on the graph then. And so this would be an example of a function that is identified everywhere. Okay, even at 0. Okay, you see some graphs have it's choppy. Okay, and at y equals 0 or x equals 0, it's not for this one. Okay, and why don't we go ahead and stop right there.